Hi guys, Shouvik here. Welcome back to your YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have the problems that minimum number of domino notations for equal row. I think the main is going to be on the dominoes problem. Yesterday it was a domino, today is also again a domino. Yeah, so first try to understand the problem statement. So in a row of dominoes, top side and bottom side represents the top and bottom ups of the ith domino. A domino is a tile with two numbers from 1 to 6, one on each half of the tile. So domino is nothing but a tile, and on that there is a numbers from 1 to 6. You can consider it as a like dice in Ludo. Like we all played Ludo, right? So on Ludo there is a dice. On dice there is a number from 1 to 6. You can consider it like dice only. So basically we have two dice. One dice represent, so there are two end dice. I more specifically have to say every die there is a top die, and for that there is a corresponding bottom dice, and every dice has a number associated with it from 1 to 6. Now we will read further. We may rotate the ith domino so that tops of I and bottoms of I swap values. So we can rotate the dominoes or the dice from, we can place the tops of ith domino to bottoms of I, or bottoms of ith domino to the tops of I. We can swap them. Right, and return the minimum number of rotations so that all the halves, all the values in the tops are same, or all the values in the bottoms are same. If it is cannot be done, then we should return a -1. I think the problem is very straightforward. Now if we can go to the test cases also, then you can get a more solid grip on the problem statement. So here you can see that is the initial configurations of dominoes or dice, whatever it is they have given to us. Now we have rotate this and this, like I equals to 1, that is of tops of I and bottoms of I of 1th index we have rotate. So these two move up and this one move down, and we done a rotations at 0, 1, 2, 3, third index also. So this moves up and this moves down. So after these rotations you can see all the tops of dominoes has number 2 equal. So that's exactly what they have asked for. You can make either tops same or you can make either bottom same. Anything's fine. And you should have to do the minimum number of rotations to make any of them is equal. So here we have make all the tops are equal by 2 rotations, one here, one here. So that's the reasons we return to. You can read the explanations also. The first figure represents the dominoes as the given by tops and bottoms before we do any rotations, and if we do rotations at second and fourth dominoes, we can make every values of the tops is equals to 2 as indicated by the second figure. Very good explanations on the test cases, and problem statement I also feels that very clear on the very first. On these example test cases, you can write your configurations on your own, and you should not be able to make all the configurations, all the dominoes to be same either on tops or bottoms. So on that case, you have to return a -1. Yeah, and constant is kind of 2 into 10 raised to the power 5, 2 into 10 raised to the power 4. So you can't submit a solutions in kind of big of n square complexity, then you are going to get an really for sure. So you have to think kind of big of n or big of n log n kind of things, right? That we all know. Yes. So that's all about the problem statement. Now tell me guys, now if we can jump on the intuitions building, what actually on very first coming to your brain? If we can go to our OneNote, what happens to our OneNote? Wow. There are lots, I guess. Go down. Think guys, like what intuitions you have to, you can put on this particular problem. Think on that. So can you guys tell me what actually the possible answers was? What actually the possible answers? Can you guys tell me? But actually like you can make all the tops or all the bottoms equal to which of the numbers? So I am asking you, you can make all the tops, okay, it's not okay. You can make all the tops, so that let's suppose our top array. So let's suppose this is our top array. This is our top. Top has some value, and corresponding of that, let's draw a bottom. So that is our bottom. I think the pen is too tiny or what? I can click a little bigger kind of pen. Yeah. So now let's suppose there is value x, y, z, a, b, c, a, b, x, y, z, k. Anything fine. So that is our bottom. Our bottom is this, and our top is this. Right? Our top is this. So So what actually, if I want to ask you, you have to make all the tops to a single value, or you have to make all the bottoms to a single value. What are the possible options you have? Can I say we have the options from 1 to 6? Can I say I have an options to 1 to 6? Because that is the dice, right? We have it. That is the dice we have at 2 rolls. That is the dice we have at 2 rolls. Because the dice or the dominoes has value from 1 to 6. So either I can make all the values to be 1, 2, 3 like this till 6. I can make everyone to be that particular value. So my answer, I will run a for loop for elements in range how far? 1 to 7. So 6 is exclusive, 7 is exclusive, so it will run from 1 to 6. So I can say I am pretty sure my all the values, I will check if I can make all the values to be equivalent to elements, either on tops or either in bottom. So I know. So now I have a directions, right? Now I have a direction. So my answer can be like all the values. I have to make all the tops or all the bottoms equivalent to element, right? Equivalent to this element. I have to make all the tops or all the bottoms equivalent to that elements. So now I think it's pretty straightforward. Now let's suppose we have a top count and I have a bottom count. I initialized all of them to be 0. I have initialized all of them to be 0, and I know for that particular for loop, for this particular for loop, my target is every element should be equals to my every elements in the either in top or either in bottom equivalent to element. So I will check. I think it's then very straightforward. For I can write a loop from I in range, whatever the dominoes they have given to us, we can run a for loop. Now the tops or the bottoms they have given to us, and we can check if my tops of I is equivalent to my element. So tell me guys, if tops domino and bottoms domino both are identical to the elements that we are choosing, and bottoms of I is also equivalent to my elements, So do you guys think we need any swap? Do you guys think we need any swap, right? Do we need any swap? Because we make either our top or either our bottom equivalent to elements. But on the current tops of I, where we are standing, my tops of I is equivalent to elements, my bottoms of I is also equivalent to elements. So we don't need any swap, right? So on that case we can continue. We don't need to do anything. So on this particular index at least, if it is not, then if my tops of I is equivalent to my elements, so that means the elements I am making everyone to be equivalent to elements, either my top or either my bottom. That I don't know. But I get my element. I got my elements at where I got it. I got it at top. Then I can increase my top count. Okay, I encountered the elements. I encountered the element which is equivalent my target elements. Element is nothing but my target elements in the top row of that ith index. Then fine. Then I am increasing the top count. If it is not, if my bottoms of I is equivalent to my elements, right? Then I can increase my bottom count. For sure. No doubt on that. Or if none of the elements on else block, then none of the elements is equivalent to my tops and bottoms. But on this particular for loop which we are running, I will try to make all the elements either in top or either in bottom is equivalent to element. But there is an index where the top and bottom is both are unequivalent to elements. Both are not equivalent to elements. So can I make them to equivalent to elements? Can I make to swap them also they can equivalent to elements? No. Then for that I can initially carry an OK variables. I can start with true, and if such case encountered where none of the elements is equivalent to elements, I can mark my OK as false. So that particular value, the value from 1 to 6 that we are considering for the targeted elements, I am making either my top or either my bottom equivalent to my target elements. That is not possible, and you can break it. You don't have to check further. So for this particular value, the answer is not possible for sure. And finally, when you have your OK, set, so that means for that particular value, for that particular elements which you are targeting to make either your top or either your bottom to be equivalent, for them you can do. So I can say then what is the minimum operations? Can you guys tell me? I think it's very straightforward, guys. You should be able to tell it. I have my top count. That top count basically stands for how many times that elements occur in top, how many times the elements occur in bottom. occur in bottom. So what is the minimum swap? What is the minimum swap? More specifically, let's suppose if I can write a small test cases. Let's suppose A occur. This can be B. This is A. This is A, and this is also A. And here you can put any value X, Y, Z. So that is the path, right? That is the path we are looking for. So A occurs in top sections 3 times. A occurs in bottom sections 1 times. So what is the minimum swap? What is the minimum swap? Can you guys tell me? Do I need to make all the bottom sections to be equivalent to A? No, because on that case we have to make 1, 2, 3 swap. But if I can try to make all the top 2 equivalent to A, then we have to make one swap. So what is the minimum? What is the minimum then? What is the minimum swap then? Mean of my top count and bottom count. Right? Very straightforward, guys. Very straightforward. And I am taking a mean of with my answer. Whatever the last elements I got an answer, we can take. If that particular element is giving me more or less value to make swap, to give me more or less value to make swap. If that is so, then we can minimize to that particular answer to be answered. Yes, as simple as that. And finally, we can return our answer. And what is the case when the answer is not possible? That is very simple, I guess. You can make your answer to be very high. Like, what is the constant on this particular problem? It is kind of, I think, 2 into 10 raised to the power 4. Yes, it is of 2 into 10 raised to the power 4. So you can create your answer as big as like 10 raised to the power 5. You can create your answer to be 10 raised to the power 5. And if after these executions, after your entire job, so before that, like make and check, after that for loop, all the for loops executed, if your answer is still lying in the range of 10 raised to the power 5, then you can return a -1 for this case. You can return a -1. And if it is not, then you can return your answer. Yes, guys, the problem is as simple as that. And tell me, guys, what is the time complexity for this particular problem? What is the time complexity? Here we are iterating a big O of n. Big O of n we are doing, and inside that, inside of what? Inside of that for loop. This for loop is running big O of 6. So the time complexity of this approach is big O of 6n, for sure, which you can submit and you can get a perfect AC. No wrong answer, nothing on that. You can get a perfect AC on that. But there is a slight optimizations you can do. I would definitely suggest, please pause the video and think on that. What optimizations you can do. But I can give you an hint. You can make this 6n to equivalent to 2n. This 6 factor is going to change to 2. So you can make the time complexity from 6n to 2n. So this 6 can change to 2n. Now think just for 5 to 10 minutes before jumping on the solutions, if you are not able to do so. But I am pretty sure you might be able to solve it. So now what actually is going to, so do I need to check for all 1 to 6 value? Right? So this actually hitting the outer for loops to be iterated to that many times, right? So I can think what is the possible answer range? We initially, like very naive and naked eyes, we are able to see that it should in the range of 1 to 6 for sure. But can I say it nothing but your tops of 0 and bottoms of 0? Your answer should be in range of tops of 0 and tops of 0 and bottoms of 0. Either your tops of 0 or either your bottoms of 0. Can I say it? Yes, obviously, because you are making all the elements to be equivalent to a particular elements from 1 to 6. But that particular elements, let's suppose, is not altogether occurred at tops of 0. Then if that particular elements is not occur at all in tops of 0 and bottoms of 0, then that is a valid number. So you are checking all the numbers from 1 to 6. But if let's suppose a number x, which is lying in the range of 1 to 6, which is, now if I can write x not equals to my tops of 0 and x not equals to my bottoms of 0, if that x are altogether a valid candidate, if it is not altogether equivalent to my tops of 0 or bottoms of 0, then that is a valid candidate? No, because here exactly the same logic we have written. If it is not equivalence to any of them, then we are breaking. We are marking it to be okay equals to false, and we are breaking. And here this x is not equivalence to my top of 0 and not equivalence to bottoms of 0. So with that, do we have either going to find the answer? No. The answer is very straightforward, no. So my answer is always be the elements which is occur either in tops of 0 or either in bottoms of 0. Agree? So that is actually the intuitions. Similarly, for bottoms of 0, so the elements should be either occur in bottoms of 0 or tops of 0. So can I say then my answer range is, so where I am iterating for range of 1 to 6 rather than iterating for range of 1 to 6, can I create my own custom iterator? Can I create my own? I can write it on next line. So my custom iterator should be my tops of 0 and bottoms of 0, either one of them. I am not going to iterate from 1 to 6, rather I am iterating to my custom iterator. So my custom iterator is a list of tops of 0 and bottoms of 0 only. And if there is one more optimizations, guys, if at any particular time my tops of 0 is equivalent to my bottoms of 0, if my tops of 0 and bottoms of 0 are same, then then my custom iterator should be a single value or not? Yes, man, yes, obviously. So you can write it in tops of 0. And now the same things you can do, the same iterations you can do where we are doing. Yes, just replace these things where we are iterating from 1 to 6. Just replace with your custom iterator that you built. Right? Yes, guys. So that optimizations we can incorporate. So on that case, our time complexity should be boiled down to big of 2n. Now we can quickly discuss our code iterations we can complete. So we have start n equals to len of tops, answer at very big of 10 raised to the power 5, and first and seconds is tops of 0 and bottoms of 0. And we have created our custom iterator to first and second, that is tops of 0 and bottoms of 0. If first and second, that is both are equivalent, then man, you can override your custom iterator only first. That should be sufficient. You can run only big of n. You can do your job in big of n. Very straightforward. Now on second go, I have iterating to my custom iterator. Now I am not iterating from 1 to 6. I am iterating to my custom iterator for elements in iterator, and top count, bottom count, 0, 0, result. Okay, everything that I have written the same things. I think this result is altogether not needed. Also, that is an redundant variables. Yes, it is not needed. I also didn't expand it. I initialized with maybe some use case I thought of when I was writing the code, but yeah, that is also not needed. So then that is also not needed. Yes. So now you can iterate for I in range in if tops of I is equivalent to your elements and bottoms of I is equivalent to elements, then that means we don't need any swap. Both are same. Then we can continue. Or if it is equivalent to elements, then increase your top count. The elements occur in bottom sections, increase your bottom count. And if that elements altogether not occurs in tops and bottoms, then make your OK to be false and break it from here itself. And if your OK is true, then only we can update our answer to mean of answer and answer with mean of top count and bottom count, exactly that we explained on one note. And if at any particular time my answer is as big as 10 raised to the power 5, that means we are not able to build the answer to be in the valid path. So on that case, we can return a -1, and finally we can return a answer. Yes, guys, the problem is as simple as that. Just the way you can think, the problem will bound to be solved. If you are able to think on the correct directions, if you are able to make your intuitions on the correct path, then obviously you can find your optimal solutions like in this way. Yes. So now we can quickly discuss the time complexity. We have already discussed and optimized. It is nothing but as worst case it can grow to as big of 2n. And on space perspective, do you guys see we are using any extra space? Nope. All are variables. Iterator you can consider, but it is of size of 2 at worst case. It can like as big as like size of 2. But so that is also a constant. So I am definitely can write a big of 1. Yes, guys. So I am pretty sure. So that is the most optimal solutions that I am able to think of for this particular problems, and I am pretty like 100% sure that is actually the most optimal solutions that you can achieve for this particular problems. And yeah, guys, my submissions is altogether like 95% faster, 95% plus faster than all the submissions over the Leetcode, and I'm pretty sure it's like that is the most optimal versions you can achieve. But you can maybe like big of n is also a solutions, but I personally feels that this particular versions is giving me more intuitions, more clarity, more readability. So please try to make your code like which is more readables, more granular, more explainables on your interview perspective. So you don't actually rush for like big of n, like very optimized versions. If like big of 1n to 2n to 3n hit is going to make your code more modular, do that. Explicitly tell on the interviewer that you are making this because your code is going to be more modular and readable, and do that. every one of us, when we are going to take interview, we are looking for more understandable, more readables, more granular, more modular code. So please go for that only. Yes guys, so I guess you guys are able to understand till this point, and if you are able to understand till this point, so please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product based company and also brushing up their DSS skills, so that they can also get most of it. And please turn on the notifications so that when we are going to live to our next video, you are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye bye.